today we are doing like real life application of exponential models. We're doing like word problems. Okay. There are two models that we've been talking about, and those are the growth and the decay. The growth and the decay. So the place that we're starting the notes looks like this. And there are two models that have been written out for you that you need to know. The first is the growth exponential growth model. And it tells you that A is the initial amount. A is written in front of the parentheses. A is the initial amount. The formulas we were doing, that we were graphing with before, were y equals A times B to the x. That's what we were doing before. So this A value, we didn't even have that in our homework yet, but the A value is still the same A value, the initial amount. Now when we talk about growth or decay models, inside the parentheses we have 1 plus R for growth, or we have 1 minus R for decay. But how that compares to what we were doing is the B is either the growth or the decay part. Remember, if B is greater than 1, it's growth. That's why growth looks like 1 plus R. If B is between 0 and 1, it's decay. And that's why the B here is 1 minus R. So what's R? R is the percent increase or decrease written as a decimal. So R is percent over 100. So if you do not change R into percent over 100, you will get this wrong. And then finally, T is the time. Yes. Yes, it is. So, example 2 says, solve a real-life problem. The value of the car in thousands of dollars can be approximated by the model y equals 25 multiplied by 0.85 to the t, where t is the number of years since the car was new. Let's look at this real fast. What is our initial amount? 25. So the car was worth 25. Was the car worth 25? 1,000. Because up here it says in thousands of dollars. They wrote 25, but it really means 25,000. If you don't understand that, you're going to mess up later. Okay, tell whether the model represents exponential growth or exponential decay. So we think about the growth or decay model. We have y equals A times. Now let's look at our B value. Is our B value greater than 1? Or between 0 and 1. B is between 0 and 1, so this is a decay. We have to identify the annual percent increase or decrease in the value of the car. So I will use the 1 minus R formula from the growth decay or the decay model. R is going to help us find the percent. Right now, it is not written as 1 minus R. It's written as 0.85. So I have to say 0.85 is equal to 1 minus R. So how do I find R? .85 is what 1 minus R is in this equation. How do I find R?
Times about 25,000.
Nope. These two things are equivalent. So how do I get R by itself?
Oh, plus 1.
Minus 1. So now I have negative 0.15 equals negative R. How do I get R by itself? Divide by -1. And we get R equals 0.15. But remember in the directions, it said that R is the percent, but in decimal form. So R is the percent over 100. So how do I find what R is as a percent? What's 0.15 as a percent? 15%. So if you say 0.15 is the percent over 100, if you multiply 0.15 times 100, just like you do for your homework, like every single day. Hold on, I make you do that every day. Well, let me say it again. Those of you that do your homework. So that would be 15%. So for part B, 15% is the rate. 15% is the rate of decrease. Now the last part is where you're going to use your calculator. It says estimate when the value of the car will be $8,000. So remember I said earlier 25 was 25,000. We have to estimate when the value of the car will be 8,000. So I have to plug in Y is 8,000, but I can't put 8,000 in there. What should I actually plug in for Y? 8. So I'm going to write my equation for part C. I'm going to write 8 equals 25 multiplied by 1 minus Actually, we can just use 0.85. Okay, we'll just use 0.85 to the T. Now, you have not learned how to solve for an exponent. You have not learned that. We are learning that in this chapter. We haven't learned it yet, so right now we're just going to approximate an answer. Later we will learn how to get an exponent by itself. But for now, what you're going to do is you're going to type in into Y1 under your Y equals button, and you're going to have to put X in instead of T. So I'm not putting the 8 in, I'm just putting the equation in. So I'm typing into Y1. Please, everybody do this, because if you don't do it yourself, you won't remember how to do it. I'm actually not even going to graph it. What I'm going to do is I'm going to look at my table. Go ahead and type 25 times 0.85 to the x power, and then go to your table. Now, once I go to my table, I'm trying to find out when, so I'm trying to find out what year, or how many years, which is our x value, when the y value is 8. So we're looking in our y column for 8. So it's approximately how many years? Approximately 7 years. So y is 8 at approximately 7 years. And eventually we'll get it so you can solve that exactly. Right now it's just approximate. Any questions on how I did that? All right, example 3. In 2000, the world population was about 6.09 billion. During the next 13 years, the world population increased about 1.18 each year. Write an exponential growth model giving the population y in billions t years after 2000. And then estimate the world population in 2005. And then estimate the year when the world population was 7 billion. So the first thing we're going to do is write an exponential growth model. So those formulas, are they still at the top of the paper? Yeah, are on your paper. We're using a growth. So that's going to be y equals a parentheses 1 plus r to the t. We have to write something that looks like that for part A. What do we know? Y equals, do we know the initial amount? And that's in billions, but we don't have to write billions. Multiply by 1 plus, do we know the rate? Do we know the rate?
1.8.
It's 1.18%, but remember when I put it in, it has to be a decimal. So we can put it in as 1.18 over 100 to the t. Now I will simplify 1 plus 1.18 over 100. I can simplify that. 1.0118. So there's part, half, the first part of part A. So that's the growth model, and then it says estimate the world population in 2005. So here's the growth model. And we need to estimate the world population in 2005. What do I need to plug in for what? To get the world population in 2005, what should I plug in? And where? Five for years, yeah, for T, perfect. So we're going to plug in 6.09, 1.0118 to the 5. Am I going to do that by hand? No. Just type in my calculator. I'm not doing that by hand. So you can type that into your calculator. I typed in my calculator, I hit enter. We get 6.458. Approximately. 6.458 billion people. 6.458 billion people. Every single person should be trying to do this on their calculator. Not watching me do it. I mean, both watching me do it. What was it? It was 6.458 billion. So that's part A. Part B says estimate the year when the world population was 7 billion. So for part B, the population goes in the Y spot, 7. And then we have equals 6.09 multiplied by 1.0118 to the T. And this is where we're going to use our graphing calculator table. So you won't be able to use T. You'll have to use X. You're not using 7. You're using Y1. But then on the table, you're looking when Y is 7. So I'll do it too, so you can see it. Type it in. So I typed it in, then I went to my table, and what do you think the answer is? $12 years? 12 years? What's going on, baby? Were you thinking 11? So you're looking on the Y1 for when it's 7. It's like 6.9 at 11 and 7.01, so it's probably a little closer to 12. 12 years. But what's it asking? It's saying estimate the year. So I'm not going to write 12 years as my answer. What am I going to write as my answer? 12 years after it started, which was in 2000, so 2012 would be the answer. Okay, when you're ready to go on, turn the tape. Time flies. Time flies. Yep, my daughter is turning 6 tomorrow. I remember 6 years ago,
everybody would get all excited about there giving, like, I don't know, from like in January 1st of 2001, like things like that, like when it was in line, like 1-1-1.
Oh, yeah.
We're getting all excited about
The best one was 11-11-11. I was in Exuma.
I remember getting so excited about that. And then, like, when I turned 13, I was 13 on 11, 12, 13.
You did?
Yeah, so I thought it was so cool. Like, that was the best day ever.
I want my daughter to be born on 11-11-11.
Yeah. 5 years, I was like, whoa.
My great-grandparents, I found this out way, way, way later. They were married on 11-11-11. But like 19. Okay. Example 4. This is the challenging one. This is the challenging one. So let's get our focus on the challenging one. The amount of grams of the radioactive isotope chromium-51 remaining after T days is, and then I give us an equation. First thing I want you to know is that chromium-51, the 51 has nothing to do with the problem. Okay? That is just the name of this isotope. Ignore the 51. Don't plug it in anywhere. Okay, that's just the name of the isotope. We need the equation y equals A multiplied by 0.5 to the T over 28. It says A is the initial amount. What's the percent that this isotope decays each day? We have to find the percent. So to find the percent, I need to figure out if this is a growth or a decay model, which it tells you. What is it? Decay. It says decays in like the third to left word. So I'm going to use y equals A times 1 minus R to the T as my model. And then we look at the model in blue, and then we look at my equation in black, and I want you to start at the T. You see something's different over here? This should just be time. Over here, it's time divided by 28. So what you have to do is you can't have time divided by 28. What you have to do right now is you have to take that, and you have to unmultiply the T over the 1, multiplied by the 1 over 28. You have to unmultiply that. So you have to rewrite it as 25 to the 128th power, and then that to the T, or T over 1 power. So we were going over exponential rules in our last chapter, so now we can apply that. And if you're not sure if that's correct, you just put the T over 1 and multiply it back, and you'll see it equals T over 28. So you have to unmultiply it so T is by itself. Then what you have to do is you have to find this answer on your calculator. So we're going to type in 0.5 to the 128. Now, we'll leave it on our calculator for a little bit. So 0.5 to the 1 over 28, we get a big old decimal. I'll just write some of the decimals down. I'll write down 0.9755. I'll write down 0.9755. But I'm going to leave it on my calculator still. So when you replace that with 0.9755, you now just have t over here. We almost have it looking like this. Almost. So at this point, 0.9755 is the same thing as 1 minus r, because our a is the same, our t is the same. So this in here is 1 minus r. So we're going to do 0.9755 is equal to 1 minus r. How do I solve for r? This is a repeat question from earlier today. How do I solve for r? Subtract 1 from both sides. And it is up on your calculator. So on my calculator, I hit -1, enter. So I didn't have to retype anything in. I'm leaving that on my calculator. I get negative 0.0245. That equals negative r. So how do I get positive r? Divide by -1. So on my calculator, just hit divided by -1. It'll take that last answer and change it for you. So now we have y equals a times 1 minus 0.0245 to the t. So that's our growth model. It asks for the percent of decrease, of decay. That's for the percent. So this right here is our rate. R equals 0.0245. That's our rate. And remember, our rate is equal to the percent divided by 100. Remember, that's how we got the rate, is we took our percent divided by 100. So how do I undo this? How do I inverse that so I can get just the percent? Multiply by 100. You take that last answer that's on your calculator, which I'm about to do, and you hit times by 100. And that will give you your percent. So my calculator hit times by 100, and I get 2.445%. 2.445%. Let's do another one. Go through that again. Okay, the amount of Y grams of the radioisotope iodine 123. Does the 123 matter? No, don't look at it. That's not important. That's just the name of the stuff. Remaining after T hours is Y equals A times 0.5 to the T over 13. Where A is the initial amount, what percent decays each hour? So it says decay, I'm going to use Y equals A times 1 minus R to the T. What's the thing that's not right? It doesn't match this right now. The T. So we're going to factor out that T to start. We're going to factor out that T. You're going to have Y equals A times 0.5 to the 1/13, and then that answer to the T. So in your calculator, you type in 0.5 to the 1/13. got 0.948. About. Okay, the next thing we have to do is take that 0.948, set it equal to 1 minus r, so we can solve for r. So how do we solve for r? Subtract the 1. So on my calculator, I just hit -1, enter. And it gives me negative 0.0519. That's just approximate. And then we divide both sides by -1. So now I have 1 minus 0.0519 to the t. Once you've done that, you can find your r. So you have this number, that's your r. But we have to write it as a percent. So our r is 0.0519, but that equals percent over 100. So to get rid of the over 100, we multiply by 100. And since it's still on my calculator, I just type in times 100. Or if you know how to multiply by 100, you don't even have to use your calculator. So my percent rate is, what is it, 5.19% through decay. Real life application. All right, one last question. One last question goes off of something that we did in the last chapter where we were doing interest. But interest is not always compounded annually. It's not like found once a year. Sometimes it's found more than once a year. And that's called compound interest. It could be compounded twice a year. Do you know what it's called if something happens twice a year? It's biannually or semi-annually? Ladies, the semi-annual sale? Okay. If it is compounded 12 times a year, do you know what they say? No, but that would be once a year if they said yearly. Monthly. They would say monthly. They would say monthly. If it was 4 times a year, it would be quarterly. So you might need some English help on these. You're not sure. So this one, oh, and also, sorry, one more thing. The N is the number of times per year. The number of times per year, and then everything else we've seen. We've seen R, which is percent over 100, the rate. T is the number of years. P is the initial amount. We've already seen everything except for the N part. So the N part is the number of times per year. So this one says you deposit $9,000 in an account. So that's our initial amount. It pays 1.46 annual interest. Find the balance after 3 years when the interest is compounded quarterly. So we're going to do 1 plus, we're going to do our rate, which is 1.46 over 100. Might be easier to find that number first. 1.46 over 100. Which is 0.0146. And that goes over the number of times it's compounded per year. So it says quarterly, so how many times per year? 4. And then we take that and we raise it to T times N. So 3 times 4, which is 12. So when you go to type it in your calculator, if you have fractions on your calculator, you can just type it in with fractions. If you don't, then it's still easy. You just type in 1 plus and then you do your 0.0146 divided by 4 and it works. And that goes to the 12. 3 times 4 is 12. Try it. Make sure you get the right answer. What it is though. Would be $9,402.21. That would be the balance. That would be the balance. I think in homework it might ask for the interest. You just have to read it. If they wanted to know the interest, what would be the interest? 402 and 21 cents. Right. Just whatever it asks for, make sure you answer the correct question. Now you already have the assignment. I already printed those out to you and gave those to you last class. So you already have that. Okay, that the rest of the time to get started. You got 10 minutes to get started on it. Lots of time. If you think that last step we did was the hardest, we had to like undo the T, they start with that part. That's on the second page.